Hi guys, welcome to the latest video in the Arduino Habitat Control series. In this video we're going to be looking at the software that's required for each of the habitat controls. Now, as the first set has been in the post to Matt, we're going to be mainly looking at his variation of the sketch that's required. Okay, I won't talk about too much about how to actually install the Arduino IDE software, as depending on if you've got a Windows, Mac or Linux machine, it's very different, but it's all very well documented on the internet. What we'll do though is have a look at actually getting the sketch and how we can adjust it and what each of the variations mean within the sketch. Right, so to start off with then, you're going to go over to a website called GitHub. Now on this website we can upload the different sketches and we can work on them as a community between each other and point out any problems we have on the software. Sorry, to basically download the file straight away to your computer, all you need to do is just click on here, the zip. That will then download the actual folder containing all the documents below through onto your computer. Now, what is handy about this website is, if while you're using the software you have a problem which you think, I can't fix this by myself, then what you can do is you can click on this tab here, Issues, and then within here you can actually create a problem. So you just create an issue, you write up the details of the actual problem that you're finding with the software, and then either myself or someone else that's working on the project can then basically edit this and try and fix it. Okay. Another good thing you can do is when you find your sketch that's relevant for your Arduino, you can basically fork it using this tab up here. And what this means is it'll copy it over to your account, and then you can work on it solely within your account. And if you do something that you think is quite good and would benefit the major sketch, then you can then send that back to me, and it can be added then back into the main repository for each device. Okay, so let's start now with having a look at it. So like I say, if you just click on the zip download, that'll download it onto your computer. Now, as you can see, I'm using a Mac, so mine would go through to a downloads folder, and then from there I'd reposition it. Right, so I'll just, first off, sorry, I'll show you on a Mac. If you had that, you'd basically just go through to where your Arduino folder is, and then within here you'd then drag the folder over. So as you can see here, I've got the mass control habitat. Okay, so to then open your file up, you actually open up your Arduino IDE. Now once that's open, you then just click the open button. If you've left yours just in your download folder or somewhere else on your computer, you just click on the open and then navigate to where the actual file is. So if you do throw it into your Arduino folder, then as you can see it pops up as just a quick access point there. So we'll just open that up and we'll make it full screen so we can have a look at it more. Right, here's the actual main sketch then set up. As you can see across the top, we've got multiple tabs. This one here is the main program, and then off that we've got the cooling, heating, lighting, and then the constants, which all control different parts of the program. At the top here I've put basically a little bit of information about the Arduino. I've placed a little wish list, so if you're working on your own sketch, it's handy just to make a few notes of the things you want to actually add into it. I've done what I've also developing, and then yet again once I've developed it, if I'm away from home, then I do a little jobs list which then I need to actually check up on when I get back home. Okay. None of this is included in the actual sketch, because you can see these little symbols at the top and the bottom. They mean, and then the way it's all greyed out means that it's actually not part of the sketch, it's literally just there for our own information. Alright, now as we scroll down the sketch, we can see here components that are needed straight away. So this basically makes these instructions load up instantly into the actual sketch. Okay, starting off we've got the wiring setup, and then we've also got the RTC lib, which is both of these for the actual real-time clock that's situated on the board. Next we've got the constants, which is this tab just up here, we'll have a look at in a second. And then next is the liquid crystal library, which is for the LCD display. Okay, so constants, we can have a look at that. In here, this basically sets up all the pins of the Arduino. So on the Arduino there's different pin numbers that you can see if you have a look at the board. So on this tab you should really never have to adjust anything, because these are kind of all hardwired in, so there's nothing really to adjust on this. The only one you may look at adjusting is here, the resistance. As you can see, it's set to 10,000. Now this could alter if you've got really long wires on your thermistors. So to finally tweak it, it could be a case of using a test meter to test the resistance down your lines, and you may have to adjust that actual reading just to get a bit of a better reading on your actual thermistors. Okay, moving down the sketch now. Right. Hopefully, when the sketches are all complete, this section here, sorry, just scrolled off the page. Yeah, the user adjustable section should be the only part really that the user needs to adjust to set up the actual device for their needs. Okay. Anything else below that and on the other tabs is maybe a little bit more complex and should be kind of avoided. Right, as you can see, nice simple where it's set in. So here, Fahrenheit, and we see to the side in grey, again we've got a bit of instructions. So as you see, it sets true, so at the moment the readings from this sketch would all come out in Fahrenheit. However, if you wanted to set this to Celsius, all you'd do is just delete the true, add in false, and then now all the readings would come out in Celsius. If you do this, however, you must remember to change the temperatures, because as you can see here, we've got cool end temperature 90, hot end temperature 72. So for here, these temperatures would need changing. So if we're in Celsius, for instance, that would have to be changed to 22. Okay, at the moment in this sketch, the cool end is not actually used because Matt doesn't want fans, so that figure's just there to make the sketch run completely. Okay. As you can see, there's a lot of variables that aren't set up yet. Two little forward slashes, they stop the item from being wet, which is why it's all greyed out at the moment, and same as you can see in other sections. Okay. Hopefully later on these settings will be added in, so you can type in then the timings that you want and you'll be able to adjust all the different settings. Here we choose which size LCD display we've got. Matt's gone for the large one, so 20 characters by 4 lines, and as you can see LCD sets true. If the LCD wasn't set to true and you had a USB cable connected, you can actually get live feed by a serial link to your computer telling you everything that's happening within the actual device. Okay. After this point we then leave the user adjustable sections. So I'll just scan through these very quickly now, because like I say, you shouldn't need to adjust these, but it's just so you're aware what they're for. Here, samples, basically this is the amount of temperature samples the device is going to take before it actually shows you up the temperature on the screen. Currently it's set to 5, so what it'll do is the computer will take 5 separate readings from the thermometer, it'll average these readings out and then it'll display them on the display. This allows it to try and get a bit of a more accurate temperature range. Okay, here next is just the wiring for the LCD, just to tell which pins are actually controlling the LCD, and same again, this is just to set up the clock. Right, here are all these ones and zeros. If you look at binary symbols, these are just to give additional characters to go on the LCD display. So as you can see here, for instance, degree, this is just to give the little degree symbol for the Fahrenheit or Celsius, and as you can see the ones indicate which will light up, so such a little small circle just to indicate the degrees. Okay, as you can see we can have up to 8 different characters which are all indicated down. These are mainly just for our sun, moon and battery, for the different power settings on the devices. Right, the main chunk of the sketch then. First off we start with the void setup. The void setup, this now actually tells the program how to initially set up the device, so everything that needs turning on, turning off as such. Okay. Straight away you can see we turn the relays off on the power board. This is really just to help in case there's a power cut or anything like that. This then stops the relays chattering as the Arduino would be resetting. So it just turns them off, and then obviously once the Arduino is then powered back up and running into its sketch, then it would actually set the relays to the way it needed them to be. Okay, so this is like just a little bit of a safety feature to stop them actually chattering. Okay, as you see here, it sets also the relays as outputs, so that just tells them it's going to be an indication from the control panel. Same again for your pins for actually your LEDs and also your fans. Here we actually just set up the characters that I talked about a second ago, so it's just defining the characters, the symbols that are drawn above, as an actual number and a name so that they can then be written into each of the different sections. Here in this section we actually set up the LCD display, so whether we have an LCD display or if we don't, we use serial link. As I said, that actually does communication via the USB cable to the computer. Alright, next we set up the actual RTC, the real-time clock, and here, this nice little line, this sets the time and date of the actual RTC so that it knows what the time is at the point it's actually compiled. So you may find this time is different from what your computer shows or your house. That's because this time is set from whichever computer compiles the software for it. So for instance, your time is set to my computer until the first time you actually upload the sketch yourself. Right, the next section, the loop. Now the loop is actually the meat of the program. So what happens here is this runs straight the way through this program. Once it gets to the end, it goes back to the top and then carries on running it, and this is then run for the full period your sketch is on until it's turned off or reset. So as we can see in Matt's sketch, first thing we're going to do is we're going to run heat 1 and cool 1. Now basically what these are is using thermistors to check the temperatures within the side of the viv and then display them on the LCD display. We'll look at those in a second. The next part of the sketch then basically prints up the RTC's information, so it sets the cursor on the LCD display, it wipes a line so there's no old information there to make sure that you don't get any corrupted symbols, and then it basically prints the year, the month, the day, the hour and the minute onto the LCD display as the top line. After that we go into a little scenario as such. So here it says if the time, so hours, are less than 7, then what it'll do is set on heat 2. Okay? Or if the hour is less than 10, it'll turn the relay off. So what this does is it counts through the different times of the day, so 7, 10, 1 o'clock, 10 o'clock, 11 o'clock, and then for each of these time limits it sets different parameters within the actual sketch. Now this is set up for the way Matt wanted it. The only bit that needs adding into this is Matt actually wanted half hours as well. So we still need to adjust the sketch to include minutes into this. So it's going to take a little bit more time. Okay. So as you can see, it runs through this. So it just says, if it's this, I'll do this. If it's not, I'll do that. Okay. At the end of that, we give a little pause because otherwise this process will be just going straight back to the top of the loop and almost instantaneously carrying out all these functions again. So we give it a delay of 4,000 milliseconds or 4 seconds, and then it will restart the loop again. Obviously you can change this setting if you want it to be more accurate and closer, or yet again, if you feel that your temperatures aren't changing that much, you can increase it. The idea of having the actual break is so that if you imagine the temperature, say, on a relay, or the time for a relay is pretty much on the mark, if this was to go instantaneously, the relay as such could be going on off, on off, on off very quickly. This obviously will then reduce the lifespan of the relays, plus it will also give an annoying click every time the relay goes on and off. So by giving it a 4-second delay, then we're just making sure it actually gives a little bit of time for the temperatures to heat up or cool down before resampling again. Right, we'll now look at one of the tabs, so just look at the cooling. So as you can see here, this would be cool 1. There is also a cool 2 because this actual shield was designed for 2 completely different setups. So the first phase of this sketch here is basically just set it up and take some samples. And as I mentioned before, it will take 5 samples with a 10 millisecond delay in between each one. Then what it'll do is it'll average out the samples to give us an average figure from the 5 samples that it's taken. Then here with a little bit of math, because the actual reading is a resistance across a resistor on the shield, then what it'll do is convert that resistance by reading the voltages on the actual circuit board. It will then do the math to work out the actual temperature. Then as we can see, we look a bit further down, we now go into yet again another sequence of if something happens or if something isn't, then it writes the information to the board. So you can see here, for instance, LCD width 20, so this is just indicating if the LCD has got less than 20 characters, it would write this code. Same again, if the temperature is set to Fahrenheit, then it would write Fahrenheit, or again, if it wasn't, it would then go into degrees. Okay, as you can see all the way down this code then, that's loads of different variables that just ask different questions and then alter it. Okay. If we actually had fans fitted, so if fans were true, then what would happen is it would look at the temperature from the probe, it would add our current change, and then it would do different things like increasing the fan to 100%, 50%, 25%, etc. Okay, and it would do all the way through this code, answering it out to do the actual features. Same again with the heating. As you can see, complete same setup at the beginning, and then we go into our actual LCD write-up. Now the difference on this one is without having the fan, so it has multiple on and offs. As you can see in this first sketch, it's all isolated out here, and that's because Matt didn't want his hot end temperature to control his heat. Instead he wanted a separate thermistor, so that was set up as heat 2. So in this sketch, heat 2 actually takes the reading for the temperature, and then depending on the actual temperature, it either sets the relay to on or it sets the relay to off to heat the viv during the night. Right, last but not least, we've got the lighting. As you can see here, lighting here is set up into multiple ones. So we've got light, so this is if we wanted to use the LEDs for during the day. We've got evening, so to give us a nice blue lighting to indicate the moon. Or yet again, just to turn the lights off. As you can see, these work by changing a reading from 0 to 250. Okay. If you found on the night time, for instance, that the blue lighting is a little bit too bright for your animal, then these readings of 255 could be decreased to say 150, and then what that'll do is it'll actually dim the lights, because these are on pulse width modulation. So what they do is they turn on and off extremely quickly, which then gives a less of a light reading. Okay, so that kind of pretty much sums up the full sketch. So once you've actually changed the settings you require on here, it's then quite easy to upload up to the computer. First thing you need to do is just go into Tools, check that you've got the Arduino Uno set up as your board, and next you also need to go in and make sure you've got the right connection selected for the USB that's connected to your device. A nice feature of this IDE is that you can check the sketch just to make sure you've not done any spellings wrong or put indications in the wrong place that you needed. So what you can do is you can verify the sketch first, so click verify. This will then run through the sketch, tell you it's done compiling, or yet again if there's a problem with the sketch then it will indicate that up. And as you can see here, the size of the sketch is 12,000 bytes, though we have a maximum of 32,000 bytes. So as you can see, these sketches can take a lot more development, add a lot more features into them before we're going to go anywhere near to the maximum memory of the actual device. Once you've actually verified the sketch, it can then be uploaded to your device. So you click the upload, as you see uploading, and we get a reading to indicate how much information has gone over. From there, everything goes well, done uploading, then the sketch is now on your board and readjusted to the way you wanted the settings. Right, I hope this helps, guys, just to show you a few things about the sketch. Obviously there's a lot of information to be learnt about these sketches, but hopefully this will give you the basis for you to then start playing around with these sketches, asking questions, and basically working on these together to try and get the best setups we can. Right, thank you very much.